Hello, welcome. Good day to you. I'm Bill Wake. We're here working on an Elm interpreter written in Swift, and we've been working the last couple of days on function calls. We've made a little progress. I'm not quite sure if we've got everything together, but it's coming along. And we hit an area where we don't handle things correctly, which is generic arguments. So we started in some tests, and let's take a look over there. All right, so we left off with two failing tests. We hadn't even fully written them, but the problem we have is if you have an if statement in a lambda expression, when you define the lambda expression, like lambda n goes to n plus 2, say, that type n, it sort of starts out generic, but then something must realize, like, hey, plus and 2, if you're adding 2, you've got to be some sort of number. And so it knows to constrain n to number. So we can see that. I think we saw it yesterday in the Elm REPL. Let's try it again. Okay, so if we say lambda n goes to n plus 2, should get a function from number to number. So it knows that this n must be a number because it was used as a number. But if we just say lambda n goes to n, it says I don't have any assumptions about the type. I make a generic. Okay, I'll do it generically. And if we do lambda n goes to n divided by 3, which is an integer operation, it knows to constrain it to int. Okay. I'm not sure the mechanism by which it does that. We don't have anything that infers those types, and it's not enough to know. I mean, when you create the thing, you think it's generic, but then you have this expression on the right hand side. It must do some sort of pseudo evaluation. Well, abstract interpretation maybe is a better way to say it, or abstract evaluation. It doesn't evaluate the values, it just evaluates the types, and in the end kind of tells you, resolves all the undefined types and says what they must be. In particular, we want to look at the if statement. So if false, then okay, so we'll need to make a lambda. If false, then n else 2. Okay, so we don't have complicated Boolean expressions per se, but let's see. So we want the type of this if statement to be number. And okay, false. This is a variable. Come on, wake up. Variable n. Well, no, it's got to be a lambda expression too, right? Integer value 2, elm type dot number. Okay, so let's just take this and run it in the REPL and make sure that's what it thinks. Okay, so I think that should be a function from int to int. No, number to number. My assertion. I get confused with their numbers because Elm, it knows a floating point is a floating point, but an integer, it sort of pretends it could be it could be a number, floating point, or int until it really has an operation that says this must be an int. But anyway, I wrote it right in the assertion. Half credit. All right, and let's see. I got to find a lambda. I know we should have one here somewhere. There we go. Lambda expression. Okay. So this whole thing is embedded in a lambda expression. N, lambda n, and then the expression is the if expression. And I don't know, there's an old pattern I learned from Kat Beck's old Smalltalk book. Smalltalk Best Pattern Practice Patterns, I think it's called. to nest, your levels of your arguments correctly like this, to show the nesting. Expected a comma. Where are we lost? Okay, so the if expression ends here, or lambda expression ends there. If expression ends here. And one more brace, I think. Okay. So this should not be a fail. All right, so I think that's the test we want. And this one is just to remind us to test the other way. All right, so if you have a non-generic and a generic in an if statement, we want the result value of the expression to be the non-generic one. Now, the lambda expression doesn't seem to have a type. Isn't that kind of interesting? I would guess that's probably not right. I don't know. It should be a function, and somehow we've got to get this constraint back in. So this may be a parent test, or a big test that we have to kind of break into pieces. So, all right. Let's see. Is there any housekeeping to do today? I don't think so. All right, and let's see. So n goes to if false, then n else 2, lambda expression n with an if expression false in 2 integer value and an Elm type dot number. So the expressions type should be the applying that rule. All right. And I'm wondering, the lambda expression not having a type is odd to me. And I think are we running? Did I say build and not test? We expect a failure. It failed when it was simpler, so there you go. All right, is not equal to unexpected character and input. Wow. Lambda n if false variable n 2. What's okay? We never did get the line numbers and column numbers and the error expressions in general. That might have been a good thing to do. All right, so let's find this phrase. Well, I think we can let's just find parser. So lowercase name starts expression. That's good. Where's the parse? End of file, empty expression, unexpected token. Huh. If can start expression, is lambda in that list? It is. Okay, let's step our way in, I guess. Seems... Am I really running? Here we go. Okay, so we'll step in. Okay, there's the parser. Value is our string coming in. That seems okay. So that seeds the parser, if you will, kind of primes it. So we always have something to look at. And we'll step in. I don't know where we are. Expected. Is it already failing? Wait a minute. Okay, I'm going to set the breakpoint somewhere else. Let's find parse. Okay, I'll take this one off. We seem to have spring in Virginia here today, so I'm in kind of a good mood, but my goodness, I'm worried we're going to be flailing around here a little bit. All right, what's token? Token is a new line. Oh. How is that? Oh. Okay. Let's write a correct expression. Okay. Let me add that to my to-do list. Though we need some error checking. I think, well, I'll put it here. And then can we start with new line? That's an issue. We haven't handled new line till now. I mean, even now. We handle spaces and we ignore them, but a new line we're still treating specially because I know there are some constructs that use it somehow. I'm not sure if it's a good. Well, I don't know. We'll see. I mean, I know there are constructs that say you must have things lined up in the same column, and that's a little weird for many languages. I mean, Python does it, but it's pretty uncommon, and I'm not quite sure how the new line fits in there, so I've left it as a separate token. But the problem I had was I picked n for my lambda, and \n is a new line character in C languages. Let me look at my other lambda tests just to make sure. Okay, that looks good. Yeah, I got my backslashes doubled, so I get actual backslashes. Okay, let's take this off. Try that test again. I'm wanting it to complain because the if expression is not right, but we'll see. And we say this is why we run our test and see it fail at some point. Okay, lambda n, if false variable n is not equal to lambda n error, then an else clauses must have compatible type. Okay, so that sounds more like it. Did I call it if statement? Yeah. All right. So let's see. Here's the thing forcing that. So in force if semantics, we find the if, then left side, else, right side. We figure out the joint type. Of the two things, and that's where we're going to take a look. And this enforce is where the error message comes from. So if the type is not Boolean, or if we got an if else incompatible type. Okay, so let's take a look at this. All right. So if one of them's an error, it's an error. If it's the same type, then it just returns that. So that should be fine. If it's float and number, it moves up to float. If it's number and float, same thing. But I think the other case we want to look at, and this should be driving this. If one is generic, I don't know if I have to do both sides again, I guess. If self is generic and other is I guess if self is generic, we want to return other. Okay. And I think we'll do an example that demonstrates the other case too. So let's try this. I think that should make our test pass because we had in first, then other. All right, let's go down to the Elm type level, and let's find tests. So we got tuple equality, error joined, float joined, different custom types. Okay, that's fine. But let's add the case we're looking for. So test generic plus other yields other. All right, so check joint type. The left is elm type dot generic. The right is elm type dot we'll say number. Okay. This test should pass. Well, if I put parentheses in. Okay, generic plus number goes to number. And let's run that. And I'm going to put it in, I think I'll even put it in the same place. I don't know. Oh no. Error is not equal to number. Okay. Elm type. So how did our other one pass? Joint type of generic and number. We expect number. So let's see what this method does. Oh, it has both sides. Okay, good. If other equals generic, return self. Okay, and I'm hoping this passes. Right, I'm going to move this up, being more generic to more specific. The first one I think is fine. Yeah. Okay. I think that's a good order. Now it's interesting to me. There's a fair bit of special casing that goes on in Elm's rules. So you have this float number thing, int, and int will come in there, but when we support int, we don't yet. We support integer values which have a number type, but we don't have any operators that can get us back down to the actual int type. So we don't ever get something of type int. But they have that, and then there's another one for like appendable, for things like arrays and strings, and then there's another one. Maybe this cheat sheet has it. It's the one I shared last week. Yeah, there's appendable for strings or lists. There's comparable for ints, floats, chars, strings, or lists of comparables, and there's comp append for strings and lists of comparables. So there's sort of half a dozen types there that have special rules on what can match up to them. And I don't know. I don't have a good framework in my head even for a way to kind of generically say int and float. Yeah, I don't know. I have to work out what this means, but basically if one's a float and one's a number, we know it's a float. And I think if one's an int and one's a number, I don't know what we know. Let's try that. If false, then 2//3 else 3. So 3 is a number, 2/3 is an int. Is it going to force it to int? Okay. We'll just make it true just to make sure it's not some goofy. Yeah, okay, so it forces it to int. All right, so combining number with an int, it says, oh, we must want int. Combine a number with a float, it says we must want float. Combine a number with a number, it says, well, we don't know exactly what it is, but it's some sort of number. Okay, so interesting. So that there may be some mechanism we can devise that says, here's the generic type, here's the specific types. If you're ever combining the more generic one, what do we call those? Constrained type is the name. If you're combining a constrained type with one of its legitimate ones, then you should take on the type of that known one, of the more specific one. And maybe that will cover that. But we can see it emerging right here. And one more constrained type would kind of push that into view, I think. The other one that goes on that we aren't addressing, and I know we'll need to, you can have situations, let's see, let's take lambda n goes to lambda m goes to n plus m. All right. Is that going to demonstrate what I want? Sorry. Yeah, I mean, in the sense that n and m, do they have to be the same type? They might have to. Number. Let's do lambda n goes to lambda m goes to that. Now, m should be any. We don't have any constraints. Yeah, so in this case, we have n is one type. M could be any other type, we don't care what. But the result has to be this type. All right, and the other thing I can see here is when I evaluate this thing, it says function A goes to B goes to A. We don't have something for our lambda that does that yet. Okay, so there's lots of balls juggling around here, but we're trying to take it one at a time. All right. Let's see. So I'm good with that one. Let's go back to our parser tests. Yeah, so this case is the lambda n goes to n case. So we'll borrow this for a starting point. Take the x off. If I do a build, does it wake up? Yeah, okay. Lambda n goes to n. So it's a lambda expression, and the result of it is a variable. Yeah, it's like there's something missing here. N. Lambda n goes to n. Lambda expression n, variable n. I think that's true, but okay, let's see if that passes. I think it should pass. But there's nothing there about what the type is. Excuse me, variable. Let's find all the variable references. Okay, that has no type. right. Well, we got this. This doesn't really test that, does it? We can't tell it's generic. I mean, we know from our code it will be generic. Well, let's do a different test then. Let's start back here. If false, then n, else n. All right. Now, I think this is going to be generic. Variable n, Elm type generic. And we'll mix this up just to get a little extra variation in there. Okay, lambda expression n, custom false, n generic. Yeah, I think this will pass. No, huh? Oh, my variables don't have types. Lambda. Oh. Lambda n if false is not equal to lambda n if, oh. Yeah. Okay. You have to make them agree. Okay. There's still something going on. Let's get to do over here. All right. If statement handles generic types, I think we've done that. At least to the level we handle generic types. All right. Evaluate one argument functions. Error checking on function call. I think this is lambda expressions. Should have a type. I think that's what I'm kind of getting at. Let's just run it once and see what we get. I think it sort of half evaluates or something. I don't know. We'll see. All right, so if I do lambda n goes to n. Yeah, we get this closure thing. And that may be right, because it's a question of evaluating the thing. So the parser finds lambda n, that's fine, but then when you evaluate a lambda, it wraps it into a closure, which seems to know the type. All right, let's try our other one. So that blew up the other day, I think. If true, then n else n. We think it should come generics. Yeah, that's all right. Generic goes to generic. Yeah, and then last if, arrow, if false, then n else 2. Okay, generic goes to number. Yeah. That's where we are now. What I think really happens, did we do that one? Lambda n if false and n else 2. Yeah, it goes to a function number to number. So this first number is the lambda n. It knows to constrain that to the result. I mean, it certainly knows the if statement returns a number, because that's the second one. But it's kind of like back constraining somehow this lambda. And I don't know how that's working, actually. Let's take that and put it in our to-do. Okay. Well, I'll put it in quotes so we know it's something. Goes to that is the type of the lambda is constrained by what the expression does. So the interesting thing there is the right hand side number. Well, okay, so this goes into the if with the generic and the to, and it comes back and says the generic. It says the result of that is the result of the to, which is number. So that's why this is number. But nothing in it. Well, you can't derive from that the number, this is a number. Like you can't take the expressions type and say, oh, it just matches this to the right hand side, because we could imagine some more complicated expression. Yeah, let me try one. Lambda n, if what's n goes to, if false, then n else 2 times 3.0. Okay, so in the inside, that expression comes back as a number, and then the multiply forces number to float. Well, how can I demonstrate? I'm trying to demonstrate that the fact that the right hand expression is a type isn't what forces the n. Is there an as? There's a string. Okay, let's try this times 3.0. Oh, interesting. Okay. I need both sides of star to be the same. I found an int on the left and a float on the right. Okay, so that's independent of the lambda. It forced the int, 2/3 is an int, forces the n to be an int, so the whole expression of the if is an int times a float, and that's not allowed. Okay, so you have to float or round. I really wish they'd just required the conversion to be consistently used to float or something, but that's not what Elm did. um, all right. How can we do this? It would help if I knew Elm. um, I don't know if there's a 2 string. Let's try that. 3 2 string. 2 string 3. No. Let's see. We got a search window somewhere. Okay. Elm convert int to string. It lacks string to number and number to string. Yikes. That's kind of weird. Well, 8 years ago it didn't. There is a function show. A goes to text. Read int. Use toString of A to Z. Well, that seems like what I did, isn't it? toString 3. Debug.toString. Interesting. Okay, let's see what that does. toString 42. Oh, man. Golly. That seems like the latest. Do I have to say import debug? No? Okay, there's string stuff to end. Well, oh, what was contains? Contains string starts with. See if the second starts the first. Interesting, but let's see if we can make that work. Import string. No. See how import declarations work in Elm. I don't know if it's a REPL issue or just straight up ignorance on my part. Default imports include string. Okay, so I would have expected. Oh, I got too much junk on there. There we go. Can I find this? Can I say string dot starts with? Yes. Okay. Now let's try this. We can do lambda n goes to string dot starts with n theory. Yeah, so that gives us a string to boolean. So it's definitely not taking the result from the right hand side. Okay, I didn't expect it was, but yeah, we can see that it takes the return value, return type, comes from the type of the right hand side, which is always a boolean. And we can see that somehow in here it knew that n, because we called string dot starts with, which requires a string or string dot string, then n must be constrained to the string type, and we should reflect that in our lambda, or in our closure evaluation thing, or whatever is going to do it. So that almost argues for another evaluation like function. We're going to get to a visitor pattern yet. Always dread that. But we have another function. Maybe there's another function that you give it an expression with variables and it constrains the variables as needed. And in the end, that's what we use for our type. And it's funny because it's almost backwards in a way. See, normally we see starts with n and that there, and we just know we don't know what type it is yet. We saw the n. It's really an unknown type at this point. And probably the variable should reflect that. But then in the context, it becomes a known type and maybe needs to be updated or something. I don't know. Maybe because it'll come in with a value. Hmm. Okay. Well, I don't know. I'm realizing this this product. Yeah, debug to string. Yeah, I guess I just forgot the debug. Oh, I missed all your comments. Sorry, Code Wrangler. Nice to have somebody who knows what they're doing with Elm. Okay, string dot from int. Good. Yeah, let's try that one just to practice. Nice. Okay. Yeah, so I think what I find that I'm doing is I'm willing to take any of the documentation Elm has on what its semantics are, and I'm willing to take the REPL and try and discover them, and I'm willing to kind of apply generic language knowledge I have from having worked on a number of compilers and try and build this thing up. But I don't know. I'm not. I'm trying to avoid going to the Elm compiler or somebody else's Elm interpreter or anything like that. Um, I don't know. It's slowing me down, but I feel like I'm struggling through and learning things anyway. But we definitely have some work to do around this. So what is it we're trying to accomplish? I guess it's that the expression. Well, we can get the type of the right hand side of a lambda expression, like the if false then else too, because the if statements and whatever else we're using, the operators will force those types in. But what we're not getting is we're not getting the constraints coming back out. So in this one, we know n has to be number, and yet our lambda comes back. Our lambda expression came back and said generic, right? So it says generic goes to number, but we know that n must be a number for this if statement to be valid, because it's returning a number. It must have a number, So I think we're gonna have to play on that, and it's a little different. I think what we're gonna do is just like we bubble up the type from the if statements. I think we're gonna have to ask each expression, do you impose any constraints on your expression? And the constraints are going to be things like variable goes to type. So some sort of map that says what's your best guess of the type of this variable, and things may have to resolve. All right, let me try one more if I can make it go. So I want to do something where, like, we have n slash slash 3. Okay, we know that's an int. Can we force? Plus, how about n plus 1? Okay, so this sub expression n plus 1, I'll parenthesize this too, just to make sure. Okay, so we know the slash slash operator forces it to be an int. It only is int to int. And so it will come back and say n should be an int. And we know that n plus 1 says n should be a number because 1 is a number by default. It's not constrained to int. And n is a number and to work with the plus sign, a number plus something has to be a number. That's something we know from n. And if these two expressions get combined by the plus sign in the middle, then we have int plus number, and like we should resolve it and say n must be an int, I think. So I think this type should be int goes to int. Int goes to int. Okay. I hope it's because I'm getting it and not because I have a complete misunderstanding. But the two expressions here, independently they're different, but when you combine them, it says, oh, it must be int, and so it's passing this constraint back so that it knows the lambda expression is an int. All right. This is probably a good time for a break. We've been going a while, so let's take 2 or 3 minutes, grab a drink, whatever, and we're gonna come back and start trying to make these types bubble back out. I think. I don't know. Is that a distraction? Let's see the list here. Evaluate function arguments. Yeah, error checking. It's something about this closure thing. Um, okay, so yeah, we'll see. All right, 2 or 3 minutes. Thanks. Hey, welcome back. All right. So what I guess we're proposing is we would like to have each expression. Let's find some expressions. I guess that's our nodes. Okay, so we would like to have expressions force constraints on variables. And right now we're hindered by the fact that we don't have any operators. And I don't know, maybe that would be better to get in place first. But the 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 idea I have is we have this evaluate, and this is the runtime. It's when you're 3 plus 2, and it's going to do the addition and tell you the answer 5. For us, basically our parser turns your string into a set of nodes like this, and then the interpreter runs evaluate on the nodes. What I think we need is something that operates at compile time, and it doesn't evaluate them for values, it evaluates things for types. And I think what it's going to do, I think you're going to give it some sort of map that is from a value, map from a variable name to its type, or its constrained type, basically saying how do you want to constrain this type, or do you constrain this type, and if you do, then you update the map with the new type that the thing should the thing should have. Um, oh boy. And I don't have a name for this either in my head yet. So this is, um, I don't know, but this is what I mentioned: abstract interpretation. So the real interpretation is 3 plus 2 is 5. The abstract interpretation is, um, you are, uh, well, it can be anything, but you could do an abstract interpretation of the length of the expression. Okay, 3 plus 2, length 3. Okay, because 3 plus 2. You could do an abstract interpretation of how many pluses do you have in your expression? 1. Okay. It could be an interpretation of what's your type, and number plus number is number. Okay, so it's interpreting some characteristic of the expression, but not actually evaluating it. And that is common in compilers, that they do some sort of abstract interpretation for these things. For types is very common. It's like, do the types, are they imposed from the top down, or do they bubble up? And lots of times they bubble up, but here we're seeing a case where it needs to, um, it's sort of bubbling up its own type, but it's also bubbling up constraints that we want to apply in other places. Um, hmm. I don't know. Oh boy. Well, our if test is one of these examples, right? So I think the flaw I'm seeing right now is I don't have a type on my lambda expressions. Is that the flaw? Yeah, I think it is. I think our lambda expression should have a type. Function goes to, it should be type function, value goes to value, like these things. Um, Lambda in function int goes to int. Okay, I think that should be the, well, It's kind of two levels. It's a little tricky. So right now we've got a function that is an int to int, and we haven't. All we've done is create it, and in a sense, maybe that's evaluating it. That it knows it's a function int to int. That's what I can't tell from the outside. Are we just, is that the result of evaluating the function, or is that just the result of kind of declaring it? Um, hmm. Yeah, huh. It's tricky. And then the question to me is this the most important thing to do right now? And that's also a little tricky. We're sort of in the middle of evaluating functions, one argument functions. We got to do multi-argument functions. We need some error checking, and well, this is where the types come in. If we don't have those types constrained, then there's a problem. The other problem is if we call, like we had, sorry, bouncing back and forth, but string.from int 3. So in our terms, this was a series of expressions, string.from int and 3, and we need to make sure that the first expression evaluates to a function, and then we apply the function to the values. But let's see. If I say function equals string.from int, and then I say function 3, okay, there's definitely evaluation going on because somebody has to take the value function, evaluate it, that gives them this string.from int function, and then apply that function to the 3. And yeah, oh boy. But at any rate, this error checking that the first thing evaluates to a function, and if it doesn't, it's a problem. I don't think we do that. And I'm also beginning to feel like my error messages, they could be a little better about telling me where the error was. We put mechanisms in, and I don't think we're using it yet. Let's find that. Right. So we have the column number. A little extra space here. We have the location, and apparently the location is not showing up in our error messages, right? So that's kind of weird. Let's get to Parser. Yeah, these things, they don't tell you what the location is. Is anybody using the location? Let's see. There's token. Let's find location. Where's the get token? Well, there we have it. Lexer.get is an empty. We ignore the location. Let's see if we call this elsewhere. I think we have one more place. Right. Okay. Yeah. So we put in part of what you need. We put it in at the lexical level. So the tokenizer gets locations for these things, but then none of our messages use it. Yeah, that's kind of annoying too. So error checking, um, error messages should tell the location. Okay. Um, yeah, that's. I feel like putting off the error stuff has been a mistake. Um, because every time we run into something like a failing test, like we had this morning, um, we had unexpected token. Well, it didn't tell me it was column one, or I would have immediately gone like, oh yeah, I forgot my double backslash. Um, and every time we fail a test with an error expression coming in, we have no idea how far it got or anything like that. So it's a barrier to moving quickly. Um, this lack. Now, there's definitely something going on with these lambda expression types, and yeah, I don't know. I'm just getting overwhelmed, I guess, is what it is. So I got to lay things out and figure out what's right. But maybe this is our next thing to look at. And I'll take this out of here. So we'll save the new line issue, but error messages should tell the location. I think that's going to help us on these things. We have the tokens. This, can we get by without this? I guess that's my question. So what happens if we don't do this? Then we end up, right now we have generic goes to number, and it's going to plug in a number. If you called it with an argument, it would plug it in, and I don't know, something would probably have a problem. Um, Multi-argument functions. Yeah, that's another issue. I don't quite know what to do. My intuition is that a function, like if you say function of x, y equals lambda whatever, well, it just equals x plus y. That's legit. Okay. I think that translates into lambda x goes to lambda y goes to x plus y. And that if we treat it like that, we will simplify things further down the line. So it's a good thing. But it's a little weird right now. Like we don't do that. Why I think that's going to help is the fact that Elm has this notion of I don't know, well, currying, I guess you call it. You can say function of xy equals, what can you do? You can call it with function of 3. That gives you a function. Okay. So that's why the arguments were backwards in here. Well, let's get back to string. Those contains that we saw. Right. See if the second string contains the first, right? Most languages you would say like theory dot contains the, or you would contains theory the, but this one, because you can create contains the and make a function. It is a function, and it takes one argument, which will pass theory in. And so if you've got the pattern, you lock down the pattern, and then you compare each line to it, say, you're using this to do that. Well, contains the, you can make that the function, and then just go on and use things as functions. So you're basically pre-binding one of the arguments in, and doing the lambdas, changing that to lambdas, I think will accomplish that. So I have some notion there anyway. It's good to have ideas. Yeah. So I don't know. I really do feel like it's making me bounce around, but I do think the error checking has been a barrier. So I think I want to do that. And we went through the evaluation, like we did this spike with the closure function call, and basically we said, well, we'll make the interpreter work even though we don't do the parsing yet, or something like that. And I think the idea is there, and maybe we're okay. But yeah. So rather than ramble around for 10 more minutes, I guess I'm going to make error checking the focus for now, and we'll set aside the function stuff. Oh gosh, it's hard to know what's the best stuff to do, but avoiding error handling or not getting as much information from it definitely slows you down in a bigger project. And we're up to episode 28 or something, so we've probably slowed ourselves down some. All right, so let's okay, let me make sure tests pass. We may take out some tests if for future use, if there's some that don't. Okay, good. So what we did was the make if handle, well, I guess it's really Elm type dot joined type handle generic mixed woof non-generic. Okay. Now, all right. So I think we trust our lexer to return real locations. Because we're returning the location value consistently. Everybody's doing it. That's a good thing. All right. And we know our parser is not using it. Okay. The reason the parser, well, a reason the parser is not using it is its error expression doesn't take a location. That's probably the easy place to fix it. The other thing we could do is, well, error messages is just a list of strings right now. So it's not even like an enum or anything. But yeah, I think we need to get a location in here. All right, and the easy way to do this is basically kind of like, I don't know, it's like a pre-refactoring kind of thing or something. People call it prefactoring or preparing or whatever. But I can add the argument and make it default for now. So location of, well, equals, I think I have an unknown. No. We'll go to the location type, see if there's anything. What? Where's lexer? Well, here's input. He must define location. Yeah. Let's make it like -1. Something completely implausible. Okay. Location. I would think you could have inferred that, but okay. So nothing's going to break from this. Just everybody's going to have an issue, I guess. Okay. So the basically it's the as string that we want to change. We'll put some tests in. And maybe 0, might be a better empty one just for now. I don't know. But I think what we want to do is make our message say error, blah, 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 at line X, column X. Okay. All right. So I think we'll back up one level. Where's error expression? Up here. No, not error expression, input. We don't know how people are using this. Right now it looks like nobody is really, right? So let's make this, I mean, custom string convertible is the thing that lets you turn objects into strings for display purposes. So I think it would be better, nobody's going to care about this. We could just say line X, column X, and go from there. So let's find an input test, empty string. Well, let's look for the word location in quotes. Any? Oh, so we didn't even bother testing that. All right, let's do that. Well, I think I'll move it up here because it's the location is sort of a subtype there. Location location description. want to say location.description equals line 1, column 2. Okay, and I think for now that'll be an improvement. That's going to fail. All right. Now, this may be one where we learn that other places are, in fact, using this, but we'll find out. Line this, column that, extra parentheses. There may be some tokenizer tests, Lexer tests that we're using it. Nope. Okay. So we made location.description. I guess we made it say line X, column Y. All right, so the location. Now we got the test here, and we want the error expression. Okay, and so, how do we want to do this? Well, I think I want this to be owned by location. We'll say unknown. And where's location? Input. Okay. I'll make static let location equals location 0, 0. Whoops, that should be unknown. Okay, and then here we're using that. All right. Okay, let's make if could I make it nil? Would that be better? Let's try that path. Location of location question mark. All right, I'm not operating from a test. Let's get that straight first. No, I am. Isn't it going to make me save it? Right. Equals nil. All right. So what I want to do is an error expression test. Whoops, whatever I did there. Error expression test. Hey, good. All right. And I think this can come before. So function test, error expression with no line, no location, just reports error message. Okay, and so we'll just make one like this. Expert messages. Evaluate. Yeah, produces itself. Okay, I just want to find out if you ask the description. Then it really just should be error messages dot if condition boolean. Right. So if you, oh no, it should be error then that. Have I got too many error messages dot if whatever the message is? Okay, I think that should pass. Okay. Error messages with location reports error message and location. All right, and this is well, I'm my blog today is comes out at like 1:30 this afternoon or something like that, 1:15 maybe. But at any rate, it's about, we hit a dead end the other day on we were evaluating result, and you get result colon type in Elm in the REPL, like 3 colon string dot string, and we had our formatter for the values print the value and the type. And it turned out that as you got into tuples and more complex types that are coming, you see that you don't want to see the type in the value, because when these things are compound, they nest, and we only want to see the type on the right hand side of the colon, not on the left hand side. And it was a little bit of a dead end. We fixed it pretty quickly, just kind of pushing our way through. But one of the things I mentioned in there is James Shore has a pattern. Let's see, we can find that. Testing without mocks Shore. He released it a couple years ago. But this is his techniques for working without mocks. And one of them, this one, collaborator-based isolation. Okay, the problem is that we would like to test all these things independently, but if you rely on the way things work, how do I want to say this? If I hard coded my answer, okay, the way I did it in the other one, I would hard code the string there, and then in this one I would do this line. Let's put the location in here. Location 2, 3. Line 2, column 3. Okay, let's get this working, and then I'll demonstrate the pattern. But the pattern is basically reaching into the implementation and say, I'll just put them both here. What the heck? Okay, instead of doing that, I could do the location dot description. Okay, so we'll pull location out. Okay, so this, now if I did location dot description here, okay, I think these will pass and fail together. So right now they'll both fail. But the deal is the benefit of the second one. Well, the benefit is that the second one, if we ever change the way we write location descriptions, then this test will be robust against that change in the line 15 version. In the first version, it's not robust against the change, and we'd have to go edit line 2, column 3. So lots of compilers would say like line number colon column number instead of spelling out the words. And we might want it to say, line in 2:3 instead. And we would have to go in and change everywhere that had an error message, and that would be kind of annoying. So I don't know. The downside is we're sort of relying on the internals a little bit. I don't think it's totally crazy, but it's fact is this location is, we're saying though the way you get there is location.description. So we're kind of including the implementation in our test a little bit. It's a trade-off, I guess. That's always is, right? So, okay. So what I want to do here though is I want to say, well, I want to say location.description if it exists. Well, I want even more than that, don't I? Let's break this out. Location string, I don't know, equals. If you have a location description, we want to use it. Okay. If you have a description, well, we have to save this location. Let location of location message self dot location equals location. Okay. And location dot description. If there is a description, we want to return space in space location dot description. I'm writing this wrong, aren't I? If location well, I wanted to do something like this. So a location description, use that if you have it otherwise empty. Has non-optional string, so the right side is never used. Okay, so that's not quite going to work. I guess I want to do this. I don't know, is that equals null otherwise? Yeah, no, I'm okay. If location is nil, then we're going to return an empty string. Otherwise, we're going to return space in space and location dot description. Okay, I think that's, we need an exclamation here. Yeah, we know it's not nil because we just checked it. Okay, so if it's nil, return nothing. Otherwise, return this. All right, I hope this passes. Excuse me. All right. Yeah, so now we report errors if we get them. All right, and so I'm going to adopt this for now. I'm trying to play with the patterns Jim has there, and we'll see. If you recall the change we had to make the other time, if you were there, we had all those places that had the type colon message, and we had to go change the way a bunch of them worked. It was all the ones that, like, the basic types were fine because they look the same no matter what. But the if, we used to print if true colon boolean, then 3 colon number, else 3 colon number. Now we just print if true, then 3 else 3 when we display the node. Okay, so we're using that isolating, collaborator-based isolation. So basically, when you have a dependency, you're going to reference the dependency's values in your assertions rather than being explicit. So it's a little more complicated, but a little more robust against particular changes. Okay. So we're at the point where error expressions know the error location. All right, and now our parser, notice our error expressions don't use the location anywhere. All right, so we want to make, how do we want to do this? I guess would it be enough? Well, we have the token is the current token. I think we could also have the current location, and at least one test that forces at least one error. So maybe we'll go for this one. It's simple. Error expression with error message is unexpected token. Okay, so let's find our parser tests. And I'm going to put this up pretty high. Successful check failed. Let's check an unknown character. Is that a token test? What's a character we can't start an expression with? Maybe then. Okay, so if our output were then, no if statement, just then, like, what are you doing? There's no expression there. Notice Elm's messages are much better than mine. But at any rate, if you passed in then to parse, then nothing would work. Okay, so let's test error message has the location. I guess we want, interesting. We got the message string. Well, do I want to fight check failed parse? See, here I am having to touch these things. It doesn't care what the location is. I mean, 2 different locations seems like a problem, right? Okay, so let's make our own version for now. We'll make an error expression with some message. Unexpected token messages.unexpected token location 1 I think we're going to get at the front of the token. We'll see. Okay, and we want to assert equal parser of then dot parse is error. All right, I expect this Well, I don't think our error expressions check. Yeah, they don't. Our error expressions don't check for that location we just added. So EQ. Let's find the tests. Error expression with locations. Okay, evaluating error expression results in error expression, but we want to have a test for equality. Error expression tests. Well, maybe it's just error expression equality. That's kind of what we're doing here. All right, so we'll get the message. Dot. Let's just pick one. Okay. Message. All right, so we've got this thing. Well, the way we do this, expr 1a, then expr 1b is the same. Okay, expr 1b, and then we make variations. So expr 2 equals, well, one variation is this thing is, well, I don't know, can we get that situation? EQ, oh, expressions. Yeah, so we can. Let's make a variable n, okay? And we'll let, I guess I'll do ABC. Expr 2b equals error expression message and then location 910. So we're going to vary the location. Well, maybe that would be better as C. Let's vary the message first. Error messages dot cannot happen. Location. Okay, so we have a series of assert equals and not equals. Well, I guess this is assert true. Expr 1a dot eq, expr 1b, and then some assert false. 1a dot eq, expr 2a. To B and to C. All right. Location, different location, message, different message. Okay, so I kind of covered the cases. I guess you could also put one that was both differ, but I don't anticipate a problem there. And I think some of these are going to pass and some of these are going to fail. The first one should pass. I think the ones where the location differs won't get detected. Yeah. Okay, so that was just that last one. It's, yeah, I can't really use equals because I'm using a EQ is kind of an override in the subclass to make sure equality. So, yeah. All right, so we don't check locations. Self.message equals message and self.location equals location. Okay, now, well, we're going to get a bunch of failing tests. This test should pass. Oh no. Assert 1A does not equal 2C. Error expression self.message equals other message equals other dot location. Okay, but we've put a bunch of parser messages at risk. The parser testing method we got is going to have to change. Okay, so error message has the location. Right. So our error, the parser parse does not return the location. Now that was the only one that failed. That surprises me a little. I thought these things got expected. Oh, no, it doesn't, because, well, it did, but it's correct because all of these other expectations have an implicit nil on the location, and this thing's expecting the location to be implicit nil. Same thing here, failed parse expression message. Yeah, so this thing comes back with nil location, parser comes back with nil location, and it's all a mosh. But if I do this one and I do location, we're going to have to catch the location now, just like we catch the token location and location. I don't think it's too much to keep track of the lexer, the token, and the location. Just that doesn't bother me too much. The only other one we saw was this one, location. All right, so now our tokens come with locations. Our error messages don't expect them. All right, so again, one failing test, I hope, in the parser, this test. Okay, and now if I make my cannot happen case, unexpected token case, this thing should have the location. All right, now there may be another test or two that checks this case. I hope there's at least one. There may not be. Yeah, okay. Find these holes in our test suite of parser tests. Okay, so now this one, the unexpected token comes back with the error location. That's good. Really, these others should, yeah, so they all should have a location, and really this should go away, and I should make this a required field, but I'm going to first get everybody using it, and then we'll make it go. So it's only the failed parses that have the issue because they get the error message. Well, let's see. Can we could pass a location in. Okay. So error message expression and nil, right? So, whoops. let's use location. All right. So everybody's going to pass in nil explicitly now, or sorry. The error expression is going to have the location that's passed in. It defaults to nil for most call sites, but now we can pick them off one at a time. So this should still all pass. Okay, and then I guess I can just find uses of check failed parse. Now this, I think I could call check failed parse for this. So this check failed parse The input is then. The error message is error messages dot, whoops, messages dot unexpected token, and the location is 1, 1. All right, that should still pass. If I could, oh, I don't want to do that. Make that optional. Or make that not needed. All right. If this passes, I can delete these 2 lines. Okay. So now I want to find everybody who calls check failed parse. Parse. Okay. And this is what the stuff I do to make things incremental. So at this point, all tests are passing. I can get the case like this one. The if condition must be Boolean. I don't even know exactly the locations we're going to get, but I can make a guess. It's certainly line 1, and then I think column 1, 2, 3, 4. Okay. Now, if the thing I would have to do is if I had multiple ones that tested this error condition, I'd have to coordinate them both. But this seems okay. Now this test I expect to fail, so I'm getting this fix one thing at a time mechanism in place. And once I have it all in, I'll strip out those optional arguments. Okay, so this one it reports the right error, but it doesn't report the line number and column number. Okay, so condition, and I think we can just look for this in our parser. Okay, if condition must be Boolean, we don't pass the location. That should pass now. If I got the location right. Okay, what did I do? Line for 1 column 20. So it's not detected until the end. Okay, so I'm willing to accept the way our errors handle at this point, but in this case, that's because we can't really judge well, we could theoretically. We're not judging the constraints until the end of the expression. So that's 3, 6, 9, 12, 15, 18, 19, 20. Okay. We don't judge them until then. This one may be a different case. Okay. So missing, and I'm okay with it. Well, let's make sure the other one works. Okay, so I can commit, right? I mean, we add location to error checking, still optional. All right, and I'm going to get more aggressive. So I got missing then or else, incompatible type, and unknown error message. Unknown error message may be a problem, but the other 3, parser tests. Okay, so I'm guessing this is the same deal. It's one shorter. No, is it? 7, 10, 14, 15, 16, 17 maybe. Okay, and this one, I'm not even going to worry about what the exact value is. Let it tell me. If it looks weird, I'll deal with it. It may come in, like it may find out that the then is not there earlier, right? Oh, I gotta change it to add it. Okay, and I'll do this one, and we'll just see. At this point, it almost doesn't matter if I do one side or the other first, really. One way or the other, it'll tell me. Yeah, so there's the other one. This one, 11719. Okay, 9. So we wanted we have a missing then. So if 6, 9, that's reasonable. This one must be a little further down, right? So it's, yeah, 15. It was actually 16. Okay. And I'm really just letting the computer count the columns, and I'm not too worried. Then else, column 1, column 26. Oh, this one explicitly used the error message. Okay, so that's those. Oh, I got a couple more. Oh, that's up top. Okay. Yeah. So add location to if statement error messages. Okay, and I'm kind of tempted to go the other way here and just find my error expressions. Okay, and make sure they all have locations. Return, if it's an error, return this with the location. Start, return this with a location. Error expression, return it. I guess it's already been formed. Already formed. Number of values. Okay. And I'm assuming I'm breaking a test every time I do one of these, presumably. Okay. Let's run these tests again. And that was like 8, I don't know, 10 maybe. 9. Split the difference. Okay. Let's see. Up here, the check is fine. Unknown custom value. In the location, 1.8. 1.3. Three, 6, 7, 8. Yeah, okay. 15. Okay. Now I think the parser test should all be passing unless I missed one. Hedge your bets, right? Okay. Everything's passing. That's fine. So add location to remaining error expressions from parser. Okay, so now I can start peeling off the stuff that made this more incremental. So here I'm going to require location. And everybody should be fine. Oh, I guess I gotta build with tests. Or run the tests. Okay, because I assume I caught every place in my tests that looked for the location. All right. Now this one, there may be some holdouts. If I take off this, I'll find out nobody passes it explicitly. Missing argument, error expression. Evaluate. Now this is interesting because we really don't know the location. Oh, okay. I think I will make this 0, 0. You know, I think we went through this before. It should, well, this really cannot happen. Should not happen. This is that subclass responsibility thing. So that one should be okay. This one, so this, this is coming in and evaluate. So the whole thing has been parsed. We don't really know the location at this point. I'm going to say there is an unknown. I think it's different than nil. Well, is it? No, maybe that's just. Maybe I do want that to be nillable. Because we're going to have places we just don't know where it happened. Yeah. And what was the other one? Variable. Okay. Anybody else? I think we just had 2 places. Tests. Okay. Test error location with no location reports. Okay, well, no location is nil. Unknown variable returns error. That one is really nil. Error expression definitely different. Well, it doesn't have to be an error expression. But a nil won't hurt there. We don't care where the error location is. We're just trying to prove that tuples only match tuples. Oh, I'm not consistent in my naming, am I? Okay, and what about this one? Location isn't declared here. Okay, let's try again. If condition must be Boolean. I don't think we care what the error is for the purposes of this. Yeah. All right. Okay, so this is saying location is required for error expression even if it's explicitly nil, i.e. not known. Okay. Well, we're through that. Okay. We probably skipped a break along the way there. I got a little into it. Let's take a 2-minute break. This finishes off the error message stuff, at least as far as we're going now, and we'll go back to some other. So, 2 minutes. All right, welcome back. Yeah, light editor. Sorry, I'm one of those. um, I wish I had a way to dim it for you, but I don't. I don't know. Maybe do it. Does it dim a little if I? A couple notches. I can still see. All right. So we've done the error handling. Error messages should tell the location. We didn't do it everywhere, but we did it in the parsing, and I think that's pretty good. It'll help. Let's see. So at this point, I think we want to go back to the functions. The lambda expression should have a type. I think where we are, maybe that's just what's next. Um, even even now, right? Those lambda expressions, they're turning into closures. I don't know if that's the right thing. Okay. Um, the closure should certainly have a type because somebody's got to. Well, it should say function whatever. So let's run it. Okay, so our read eval print loop, we got lambda n goes to if true, then n else 2. And evaluate that. All right, so it says closure. It's got some symbol table we don't care about. Lambda n, the type is generic, goes to number. We know we would like this to be number goes to number. So whoever came up with that, that function declaration there is the type, right? It must be that closure. All right, let's clean up this. We'll close everything and let's open lambda expression. All right. Ah, it does have a type. Well, everyone has a type. I don't think his type is right. Okay. Yeah, so the expression coming in is known. So on the right-hand side of 18, the expression.type is the correct type, assuming everybody produces their types on the way up. That's fine. But there's this type generic that's the one I got to get. Like we want that to be number for our example there, and if it were a float, we want it to be float. That should be generic goes to float. Should be float goes to float. All right. And the other thing is these generics, there's more complexity there than we've started to deal with, but at least this type resolution kind of stuff should happen. So I think what I need to do, I think I need to ask any expression, do you have any constraints on these variables? And the only one there now is the single lambda expression. All right. Okay. So, this is well, it's it's going to involve all the expressions again. So, like, oh, we're going back to all these things again. Right. So this Elm type dot generic, it needs to be some other computed thing that takes the default generic for name and expression type. So what are we calling this map that comes back? It's a type constraint. Well, type constraints, I think I can make that. So I don't know. I don't want to be too bottom up on this, but if the real interesting case is variables, right? I mean, they introduce the constraints. So I guess I could do something that says by default, if you ask me, you give me some type constraints, I'm going to leave them alone. And if I'm a variable, I'm going to have an opinion. If eventually everybody's going to have an opinion. All right, so let's make that happen. Let's see. So this so I guess the function is something like constrain types, and you give it a type constraints, and it produces or revises the type constraints. So we need a test. Let's see. Is this interpreting? I guess it's under this area. Let's start with a integer value. Okay. So this is integer value imposes no type constraints. Okay, so we need an integer value. Integer value 43. Ha, didn't see that coming. And we want to say that the constraints could I give it an initialization? I guess I could say n goes to Elm type dot generic. Okay. That's coming. All right. And then if we want to say I guess I want to say that type constraints dot count is 1, and type, maybe I need to just say equals. This is kind of a pass by value problem, right? I'm passing the type constraint object by value, but it can change. So I guess I'll keep this way for now. Type constraints of n is Elm type dot generic. Okay. Now we need a type constraints class, and I'm just going to put it here for the moment. And we're just going to get the test working, and then we'll be fine. Okay, so let's see. This thing takes, it has an init of which is the constraints, which is a map. Oh, I'm always mixing these up. Is that the map? Okay. Constraints of string to Elm types. All right. And it's got a count. And we'll just return 0 for now. And it's got a subscript. What was my alternative there? Subscript. And I gotta look these things up, but I think I give it an int, an index of type string, and it yields an Elm type. Unknown. Okay. Immutable expr never used. Yeah, we need to do expr dot constrain types with type constraints. Okay. Yes, has no member. All right. Okay, so basically I set up the test, I do some framing to just return junk. I don't care that it's here. And now I need to get this constrain method put onto at least integer value, but I'm really going to put it up on expression. Okay, so he's got evaluate and type. Let's just put it up here. Constrain, and this takes, oh, I'm going to have to move that thing then. Function constrain. It takes a constraints of type constraint and doesn't return anything. It may change it. Okay. Right, not in scope. So let's get this thing. Oh, it's got an S on it too. Okay. Let's put this up here. New file. Now this was going nuts, but I did upgrade something, so we'll see. No. Type constraints.swift. Okay, and put this in here. Expression has type constraints. All right, that should be good enough to get my test to fail. Whoops. It just hasn't built. I hope. All right. Failed. 0 is not equal to 1. Unknown is not equal to generic. Now, I may not care about the count. Like I really want to let you update these things, but I don't want to let you add to them. And my constraints right now, I don't have a mechanism to let you add. So I think this count is redundant. If we can't come up with the list beforehand, maybe there'll be a need for that. But I think the way it is now, there is not. Okay, so I'm going to delete this call. All right, and this one failed. 0. Well, okay, I'll run it again. Unknown is not equal to generic. Okay. All right. So we're going to make this thing. We're going to save the constraints. And I think we'll be let here and here. Okay. And then this thing should return constraint sub index. Now, yeah. Do we want to return an optional? Ugh. I don't think so. I think you only, the way this is intended, you will only update indexes that are in there, and you're only going to look at them that are in there. I'm going to say this for now. All right, so I think this will pass. It's not super useful, but it'll pass. Okay. Let's get down to the ones that are going to cause some problems. Okay, here's constrain. So what I'm asking you to do is any expression that feels like it forces a constraint on any existing parameter should update the constraint table with that constraint. By default, we don't. I'll say no additional constraints or restrictions. Yeah, constraints by default. Okay. Let's see. So I got to come up with some examples, right? So if I just see lambda n goes to n, and I have a variable, the incoming constraint is it's generic by default, and is left generic because we just don't know what n is. If I do n plus 2, I'm coming into the plus. So is the plus going to have to do the work? I mean, maybe it is. The plus is the one that cares. The plus says, I see I have a generic and a number. I don't know how to add generics, but I do know how to add numbers. And I know ints and floats, but number is the more generic type. But we can't let you be fully generic. So I'm going to say my left-hand side should add a constraint to n. I don't know. Is that right? So let's take the if case. Let's take this case. If false, then n, else 2. Okay, so the if statement says I need then clause and else clause to be compatible types. Hey, what's your type? Generic. What's your type? Number. Okay, children, you need to make sure you're returning a number. And the constraint that the left-hand side will add is n is number. I don't know. We're not necessarily passing enough stuff around yet. What else can force this? I mean, any function call. Okay. What do we have over there? String.from int. Okay, so string.from int 3 in, let's say, it wants an int, and it's a function call, and the function call says, okay, what are my argument types? I got one argument, it's an int. Okay, expression on the right hand side, you need to make sure that my argument is an int, and the only thing in the argument is the variable. So the variable needs to constrain itself. Okay, well, let's try and get this case here. We don't have the complexity yet to do functions or operators, but we do have this. I guess the two cases we can handle. How about some variety here? Lambda x goes to x. That probably would be safer than this lambda n, because I already messed that up once, right? Let's do that for these. Okay, so lambda x goes to x. Generic expression says I'm fine with whatever. I'm fine with the type you gave me. You gave me a generic, I'm fine. The second one says we got to do these constraints. I need to constrain left-hand side and right-hand side to their joint type. So I need to tell it to constrain. I don't know. I feel like I'm going up and down the tree, and that's usually a recipe for getting confused. That's me. All right. So lambda x goes to x. Lambda x goes to if false. All right. So let's take this case. Lambda x goes to x. Let's just try that. So if I have a variable and I tell it, you need to constrain your expression to anything. It comes back and says, okay, no problem. I'm constrained. Oh gosh. Well, okay. So does it have to be a lambda involved? I mean, this value can't put any constraints going down. The plus can. And again, I think the constraints going down are look at your node in the joint type and force both arguments to be of that joint type or compatible with that joint type. And maybe I got to think of it as being more specific type. Well, I mean, we really are defining a type system. Yeah. So, and it's me stumbling through it is basically what's going on. But what we can see is, I mean, in languages without generics, put it that way, if we didn't have generics, we would know the type of X was, say, int on this line 7. And we could just bubble the types up and make sure they're compatible and we're good. But with generics coming in, we have to be able to say, no, you can't just be any old generic type. You really do need to be a number for this X to be legit. Yeah, so somehow we're enforcing things on children types, but like the only way to find out what that type should be is to get the bottom up joint type. So we ask the if statement, what is your type? And he says, oh, well, I'm combining a generic with a number. My type is number. And that's the only way we know that number is the type that has to bubble back down to X. So it's a twisty little passage, I guess. Yeah, so I think what this tells me is, I think the next test case is this one. So we want to tell the lambda expression wants to say, constrain yourself so that you're compatible. What's your type? It's generic. Constrain the variables so they support generic. Easy. Yeah. Okay, so I think we can compute the types going up if we use those rules like generic with float is float, and then we have to enforce them going down. So let's take this test case. I don't know, these tricky problems. Okay, so this is a lambda expression, and his test. Lambda test. Okay. So, generic type is acceptable. I don't know. We'll work on these names. Let's get something going first. So, we'll make a lambda expression. Name and variable name. Okay. Now we want to I guess we're trying to prove the type. So it's kind of like this. Expression type, generic. This should be generic goes to generic. I don't mind calling that expression. Expression type is generic goes to generic. Okay, and I'm going to format these to line up a little. Okay. Okay, so that's one test, and we're good with that one. Well, we haven't proven anything, but generic type must be constrained. All right, and this one is our lambda, our if. So the expression now is if statement of was it if expression. Okay, it takes a condition. Let me go grab an example. Yeah, thanks. Okay, we don't need that. Try and get these pieces lined up a little. Okay, so if expression true Boolean type, this should be variable name integer value to elm type.number. That's correct. And then we don't need to evaluate just yet. Okay. So our lambda expression is name, lambda name goes to if true, then name, else to. And bool type is defaulted up here. I don't know. And the setup's getting a little long. All right, now, do we have one more? Why did that? There we go. Okay. So now this thing should be elm type dot number goes to elm type dot number. So integer has type number, name should be, the if statement has type number because generic plus number is number. And then if this thing is working somehow, we should be able to say the function type is number because name must be constrained to number. Okay, so this test is for the future. Let's see if we can do the easy one first. Oh, goodness. Okay, maybe this is where we leave our failing test for today, but we'll try and get it going. Should fail. No, it might even pass, actually. We got generic and generic. I don't know what variable does by default. Yeah, so we've at least pinned down the current case. Okay. Now, I'm not sure it's going through the mechanism it needs to. So, okay, before I go there, so variable apparently defaults to generic. Yep. Okay. So that makes sense. Defaults to generic. It didn't really try and constrain things. We could make it. Now it's kind of a refactoring. We could say, hey, you got the variable type as generic. Force name to be compatible with generic. I think that would be okay. All right. Let's see what that looks like. Where's lambda expression? Okay. So, well, let's argument type equals elm type dot generic. Let's pull this out. Okay. Now, really, argument type is the expression. We want to say expression, how would you constrain yourself to be compatible with expression.type? So I don't know. We'll have to figure this out, but I think this is where constrain. I want these constraints to go in. We'll have to leave it there, I think. I don't know. Maybe we're constraining the type constraints object to expression.type. Is that meaningful? Okay. I think we'll need that extra argument because you need to know if you're going to constrain this expression to this type, you pretty much need to know where you're headed. Okay, so in our case here, generic, we're saying the expression type is generic. Hey, expression variable, what constraints do we need on the argument type to produce the right type? And maybe this map is premature. maybe because we only have one argument functions at this point, maybe I just need to say name, the name going in. All right, we'll leave it there. So tomorrow, 1 to 3 p.m. Eastern, we'll pick up, and we'll make something happen here. Okay, so we'll uncomment this just so we have a failing test to pick up on. Well, we're passing right now, so I'll check this in and then change it back to a failing test, and we'll pick up there tomorrow. So thanks for joining me. Take care. See you later. Bye.